In the name of Allah, the compassionate and the merciful. Hello guys. In this video, I'm gonna show you how can we analyze the pushover with nonlinear rotational spring in C programming. So, as you see, we have one elastic element with axial and flexural rigidity, and in node 1 we have one nonlinear rotational spring and simply support, and in node 2 we have fixed support, but in just 1 degree 1 degree is realist. Degree of freedom number 4 is realist, and incremental displacement is applied in degree of freedom number 4. And at the bottom of this picture you see the moment rotation relations of this rotational spring. As you see, hardening and softening is shown in for defining moment rotation relation. And if we wanna model it in C, as you see in my code, I use many functions for step by step defining, analyzing, and then outputting our analysis and result. And as you see, for importing data, I used this function for defining axial and flexural rigidity and initial incremental displacement, and number of increment is imported for importing data to coordinate of these structures is imported, and then in the import data 3 moment rotation relation of this spring is imported. And you see many functions. For example, for analysis we use the many message reports. For example, checking import data 1 if the negative value is defined. So if this happens, we have error here. And then for moment rotation relation, if we have negative value, so we have in this situation we have error here. And even for outputting our result, pushover result in Excel, as you see, we have function here. For HTML we have function here, or even for displaying of this pushover analysis as a graph in HTML mode, we have a function here. And for calculating the spring stiffness, nonlinear spring stiffness of this situation, we have a function here, and spring coefficient we have a function here. Or any case of these structures, we have many functions which can be used for our modeling or any modeling. And at the last step we use the function with the name of analysis. In this function all data is imported to this function for pushover analysis. And as you see, I used for defining my increment analysis, and I used the initial displacement, and in each step it is it goes more and more. And base shear of this analysis is calculated. It is very simple form, and it is very important. The stiffness of this nonlinear rotational spring is calculated in each step and then defined to this analysis. And as you see, the displacement of this analysis is degree of freedom number 4, and base shear is degree of freedom number 1. And as you see, displacement and base shear of this analysis step by step is calculated, and if rotation of this nonlinear rotational hinge or spring is reached to ultimate rotation, then analysis is going to be stopped because the spring rotation reached to ultimate rotation. I mean, in this situation, if the rotation of the spring during the analysis reached to theta c, then the analysis is going to be stopped. And at the last step, we use the HTML format for displaying our pushover analysis. So as you see in this graph, we have displacement of degree of freedom number 4 and base shear degree of freedom of number 1, and pushover analysis of this is shown. As you see, we have here we are hardening, and then suddenly going to be softening. It is because of the hinge relations, and structural relations is very efficient for defining these parameters. And at the last, I wanna say that the C programming is very efficient for defining and formulating nonlinear finite element, and very, very, very useful, and it is very common for defining and formulating and programming this kind of examples and outputting it. Even you can output your files in Excel file, CSV file, or even MATLAB file, or text file, or even in HTML format. So thanks a lot. Goodbye.